Hey, hello. So this is the second to last of the SAT worksheets. This is SAT worksheet 215, plug numbers, plug answers, and scaling equations. This worksheet is one of my favorites, and I don't think you'd get any of your math teachers to feel the same way about this one. Because what does this worksheet do? It effectively gives you alternative routes to get the answers to problems. When you have a multiple choice test, you don't always need to do the algebra. You don't always need to do things the long way. Sometimes you can use the answers and the fact that the test is multiple choice to help kind of inform your approach and your method. So what we'll do is we'll take a look at three types of questions. We'll take a look at the plugging numbers questions. I'll start off by showing you a problem that you can try to do. If you're able to get the answer algebraically, great. If not, I'll show you a much easier way to do it. And then I'll show you some test problems that are also easier with a method I'm going to show you. We'll look at plug answers, which is using the answer choices to kind of plugging them in. And last but not least, we'll look at this concept of scaling equations, which is a harder concept. Doesn't come up a lot on the test. But when it does, it tends to fool a lot of students. So we'll make sense of that as well. All right, so let me start off with this plugging numbers concept. I'm going to go back up to this example one in a second, but I need to kind of get your buy-in. I need to get you to believe that what I'm about to teach you is worth your time, because it's something that you would not have learned in school, and it's going to run counter to most everything you've done up to this point. So you're going to be resistant to wanting to develop this skill. But I'm telling you that it's very useful on the SAT. So if you want, pause the video, take a moment to see if you can get the answer to this problem. I will say that my guess is that less than 5% of people watching this will be able to actually get the answer to this problem. So if you want to pause, take a moment to do it now. Otherwise, I'm going to show you how I'm going to do it. So anyway, we have an equation here, and it says an electrical engineer uses the formula above to determine the total resistance in a circuit with parallel resistors having individual resistances of X and Y, where X and Y cannot equal zero. Which of the following represents Y in terms of X and R? So essentially, what it's asking simply is just, can you isolate Y? Can you get Y by itself? I've done this algebraically. It's below. It took me about 12 steps. Maybe you can do it in less. I found that it took 12 steps and maybe about 4 or 5 minutes of my time. So I'm going to show you a much easier way, especially if this is on section 4, the calculator section. So we know that this equation is equivalent to one of these equations. So if we plug in numbers and balance this equation, the same equation rearranged should also balance. So when I plug in numbers, I tend to avoid zero. In this case, dividing by zero would get you no solution. And I also tend to avoid one. One won't get you the wrong answer, but it will get multiple answer choices to match a lot of times. And we just want to find one match. If you plug in one and you get multiple matches, you would just plug in a different number. But anyway, watch this. So we're going to just say x equals 2. We're going to say y equals 3. And we're going to allow that to determine r. So we have r equals 1 over 1/2 plus 1/3. Okay, so really we have to rewrite this as 1 over 3/6 plus 2/6, so we can add the bottom. So then what we have here is we have r equals 1 over 5/6. And I'm doing this without a calculator, but you'll have a calculator, which will make this even easier. So if r is 1 over 5/6, r is really 1 times 6 over 5. So 6/5. So we have r equals 6/5. So now that we've balanced this one, we can just go to the answer choices and see which one balances, and then we'll have our answer. I'll do that by hand. I don't want to lose r. Okay. So if we go to this first answer choice A here, we have r minus x. Well, 6/5 minus 2 is going to get us a negative number. Oh, and I'm sorry, it says what represents y. So 3 equals, 3 equals, 3 equals, 3 equals. So the right one has to balance out to equal 3. So 6/5 minus 2 is going to give us a negative number. That's definitely not going to equal 3. Let's look at B. B, we have 2. And again, you'd have a calculator on this problem, but you'd have 2 times 6/5 all over 2 minus 6/5. Well, in this case, we get 12 over 5. I'm going to call this 2 10 over 5, so we can do the subtraction. So we get 12 over 5 over 4 over 5. And that's really 12 over 5 times 5 over 4, because if you divide by a fraction, you can multiply by the reciprocal. The 5's cancel out, and we really get 3. So B does balance out in this case. What you'd want to do on the test is try the numbers with C and D as well, because for sake of time and not wanting this video to run too long, I'm not going to try out C and D. But if you put in these numbers, 2 and 6/5 for C and D, you'll get that they don't equal 3. Very easy way to do it. If you are kind of saying, no, I want to get this one algebraically, I want to do it algebraically, fine, but it may take 5 minutes of your time on a section when, if this is section 4, you would have 55 minutes to do 38 problems. So maybe you really don't want to be spending 5 minutes on a problem. But anyway, if you're interested, those are the 12 steps to do it algebraically. You can obviously look at that on your own time. But let me scroll up and just explain this idea. Whenever you have expressions or equations that are equivalent, you can always, if you don't want to do it algebraically, and I know everyone knows immediately this is AB plus AC because of the distributive property, but I just want to show this very simply. If you get something like the problem we just did, you don't need to do it algebraically because it's a multiple choice test. So if you need to find equivalent expressions, we'll make A2, we'll make B3, and we'll make C4. What do we get? We get 3 plus 4, which is 7, times 2. So when we input these numbers, we get an output of 14. So if we were to just look at A right here, we would have 2 times 3, which is 6, times 4, which is 24. Well, 24, we don't get a matching output. How come the output doesn't match with the inputs? Well, because it's not the same equation. The same, or expression, the same inputs should yield the same output if they're the same expression. If we look at B, we have 2 times 3 out front, which is 6, plus 2 times 4, which is 8. Add them together and you get 14. The fact that it matches is not a coincidence. It's the same expression. Okay, so I've picked a couple hard ones to try here. I don't think we're going to do all of these. I think we'll probably do these two. Okay. So again, feel free to pause the video and see if you can get 2 on your own. I did cover this in worksheet 203. It involves you needing to know how to do difference of squares, but I'm going to show you a way around everything. So if we just said we have this equation and we want to know what's equivalent to this, we can just balance this equation out, put in the numbers again, get an output, and then see which one matches. So I'm going to make x, I'm going to have to minus 6y from it and then divide by 9z. So I think what I'm going to do here is I'm just going to make x equal 10. I think that's going to make our life easy. I'm going to make y equal 2. So what we have is 30 minus 12, which is 18, and 18 equals 9z. So z will have to equal 2 as well. We don't like to get doubles, but we'll see if it's a problem when we plug through. So z equals 2. So we got everything to balance. Now, if we look at this equation here, I don't want to erase all that. Do this quickly. Or sorry, if we look at this expression here, we have 10 squared, which is 100, minus 4 times 10, which is 40, times 2, 80, plus 4 times 4, 16. So really what we have is 116 minus 80, which gets us 36. Okay? Well, we need we want to know which of these is equivalent to 36. So if you think about it, if I just put in 2 for Z, this one's 18, doesn't match. This one is 12, doesn't match. This one gets us 36. And I'm not even going to do the math on this because 81 times 4, we know that's already going to be way over 36. That's the easiest way to do that. If you want to see how to do it not by plugging, I'll show you, but I'm telling you, you just may not recognize it on the test. So it's probably worth your time just to plug. But if you divide by 2 here, or sorry, divide by 3 here, you get x minus 2y, x minus 2y equals 3z. What you'd have to notice upon doing that is that this is a difference of squares. This is x plus, or sorry, not a difference of squares. This is a perfect square. This is x minus 2y squared. So if you can do that and then you notice that this creates this, then amazing. You could definitely do this problem. No big deal. But a lot of people don't recognize that, and it's a lot easier just to plug numbers. But anyway, if you get to this point, you have x minus 2y. Well, x minus 2y is 3z, so you can substitute. So you have 3z in brackets squared, so you get 9z squared, and that's how you'd match C. But again, I would honestly just tell you to plug and be done with it. And that's why you want to develop this skill, because there are certain problems where it's just easier to use this skill. I'm going to skip 3 for now, but I will say this. Plug numbers, you'll get it. If you don't plug numbers, you would have to be able to do polynomial division. Some of you will have learned this in school. Most of you will have not. Do you need to learn this for the test? Not really. Out of the past, since this test has been out in 2016, I've only come across maybe 4 or 5 polynomial division problems, and I'd say only one of them you couldn't get with plug. But even that one you could kind of still figure out. But all other ones you could just plug numbers and get it. So I would just plug numbers on this. Don't even bother with the polynomial division. Unless you want to learn it, then you can look it up. And obviously, you can always ask your tutor to teach you the mathematical way in addition to the plug. But for the sake of a timed exam, sometimes it's easier just to do the quick path of least resistance. Okay, so this problem is really hard to see. I acknowledge that. Let me see if I can make it a little bigger. All right, we'll take it from here. So it says a project coordinator at a banquet hall is given the task of arranging seating for an award ceremony. The figure above shows the first 3 possible arrangements of tables and the maximum number of seats in each arrangement. If the number of seats in each successive arrangement is increased by 6 over the preceding arrangement, which of the following represents the maximum number of seats around n tables? Okay, so essentially they're giving us inputs and outputs on this problem. So n is the arrangement, and then our output is seats. Or n is tables. N is tables, output is number of seats. So if you have 1 table, you have 8 seats. 2 tables, it goes up by 6, you have 14 seats, and you can count those if you want to check, but it says it goes up by 6 each time. 3 tables, 20 seats. So now that you have this T-chart, and you have numbers to plug, the easiest thing is to just take them right to the answer choices. So if I plug in 1 for n, I don't get 8 out on this first one. If I plug in 1 for n, what do? I get 3 plus 1, which is 4, times 2 is 8. I plug in 2, I get 6, plus 1 is 7, times 2 is 14. I plug in 3, I get 9 plus 1 is 10, times 2 is 20. They all work for B, but let's just quickly check these other ones. I plug in 1 here, I get 2 times 6, which is 12. I plug in 1 here, I get 4 times 6, which is 24, which also is an 8. So the easiest way to do this problem is just to plug. The hard way is to realize that B is 6n plus 2. And if you think about it, every table gets you 6 seats, right? If you look at adding a table, it gets you 6 seats, but you'll always start off with the 2 seats on the end. But conceptually, that's a hard thing to realize in the middle of a test, that you have 6 seats for every new table, but the 2 seats on the end are just extra seats beyond how many tables you have. So anyway, I think plug is the way to go there. Okay, let's go on to the next concept. So this next concept is this idea of plugging in answers. So sometimes you'll get a problem where it's just easier to look to the answer choices and just do them. So we'll look at a few of these. I'm going to come back to 59. I call 59 the giant killer. It's a concept that a lot of really strong students miss just because they don't know what to look out for. But we'll do 77 first, and then we'll come back to 59. Okay. For 5 consecutive even integers, the sum of the first and third integer is 20 less than 3 times the fourth integer. What is the fifth integer? Okay. So here's what we know. We know that the sum of the first and the third, so I'll do f for first plus t, is 20 less than 3 times the fourth. So I'll call the fourth one x. That will be the fourth. Okay, so the sum of the first and third integer is 20 less than 3 times the fourth. What is the fifth integer? So one of these is a fifth integer. The easiest way to do this problem is to know that there are 5 consecutive even integers. So let's just count backwards. 10, 8, 6, 4. Okay? So if we look at this one, the first plus the third is going to be 12. 4 plus 8 is 12. 3 times the fourth one, 3 times 10 is 30. 30 minus 20 is going to be 10. So those don't equal. So immediately, by just using the answer choices, we're able to eliminate A. Well, let's rinse and repeat with B. So we have 6, 8, 10, and 12. Let's get rid of this. So the first plus the third is going to be 16, 6 plus 10. The fourth is 12. 3 times 12 is 36. 36 minus 20, right? 36 minus 20, that's going to get us 16. So really easy to do this problem just by consulting the answer choices. They're there. It's a multiple choice test, so you don't have to pretend like they're not. I know on the GCSEs, it's not multiple choice, so you're not used to using the answer choices to inform your thinking. But on this test, you can absolutely do that. All right. We're going to look at the giant killer, 59, real quickly, and then we'll move on to the last concept on this worksheet. So probably about another 5 to 10 minutes. Okay. So when you have a radical, if I say the square root of 25, this is not plus or minus 5. It is not that, okay? If the square root is already in place, the notation is that it just wants your positive answer. I know -5 times -5 equals 25, but if the square root's already in place, it only wants your positive answer. What are the implications on this problem? Well, the implications on this problem is that when you take the square root of 4x, it only wants the output to be positive. It does not want the output to be negative. So if you plug in 1 here, you're going to get 1 minus 3. You're going to get -2. Well, before we go any further, this can't be true. Yeah, I know if you plugged in 1 for x both ways, you get the square root of 4 equals -2. But when they say the square root, they don't want the negative answer. So this is actually gone. If we do it with 9, we get the square root of 36, right? 4 times 9 is 36, equals 9 minus 3, 6. And sure enough, the positive answer, root of 6, equals 6. So this one would be not 1. Ooh, don't want to circle that. This one would be 2 only. Here's a mistake a lot of people make, and it's really, really, really common. If you just put your head down, you don't recognize that it only wants a positive answer when it has a root in place, and you don't plug in your answer choices. You go, okay, let me do it algebraically. You square both sides, so you get 4x equals x minus 3 squared. And if we do that out, we get x squared minus 6x plus 9 equals 4x. Move the 4x over, right? It's a binomial or a quadratic. You get x squared minus 10x plus 9. And you say, oh, no big deal. I've done this a million times before. You say, okay, well, adds to 10 and multiplies to 9. And if you think about it, that's going to be x minus 1, or adds to negative 10, x minus 9. And you go, okay, my answers are 1 and 9. Perfect. And then you circle C. Well, you would have missed this problem. So it's really important to be very cognizant of plugging in your answer choices, especially on a problem that already has a radical. It doesn't want your negative solution. So 1 is actually an extraneous solution, is what it's called. Okay, last concept. So this concept doesn't come up that often, but people tend to get really tripped up on these problem types. They're the scaling figures problems or scaling equations. I'll just go through this example, and then you can feel free to try the other 7 problems that are below. But let's look at this example. The equation for the volume of a cone is V equals 1/3 r squared h. If the radius of a cone doubles, how does the volume of the new volume compared to the original volume of the cone? Okay, easiest way to do this is to just plug numbers, and then you can compare the outputs. So I almost call this an equation proportion plug, meaning that they give you an equation, they give you an input, they tell you by what factor the input changes, and then they want to know by what factor the output changes. Make a note, sometimes they'll do the reverse, where they'll change the output by a certain factor, and they'll want to know how that affects the input. You'll have practice on that below. But let's look at it where we change the input by a proportion, and we want to know how the outputs change proportionally. So what you're going to do is this. You're going to make a t-chart. And for the original, you're going to have your R, and you're going to have your volume. So on the original, if we just plug in 1, yes, I did say the number 1. On these proportions, 1 is okay. So if we plug in 1 for R, what we're going to end up with is we're going to end up with 1/3 h. Okay, then on the new one, if we double R, right, because it says the radius doubles, so if we double R, then our new output becomes 4 times 1/3 h. So we get volume 4/3 h. So if we're comparing the outputs, we have h divided by 3 to 4h divided by 3. That's really h to 4h, or a 1 to 4. So in other words, if our radius doubles, our output or our volume quadruples. There's a faster way to do this even. The faster way is to realize that 1/3 and h are just constants. They're just numbers that you end up multiplying the final output by, but they don't change, right? If you think about it, if I have pi versus, let's say 5 pi, that's a 1 to 5 ratio. It doesn't matter if I multiply both by pi or not. So in this case, it doesn't matter if I multiply both by 1/3 h or not, the proportion is still going to be the same. So an even easier way to do this is to say, okay, my R is 1. I ignore my 1/3 and my h because they're constants, so my volume is 1. Okay, my new R is going to double, so it's 2. R squared, 2 squared is 4, so my new volume is 4. And then I can see that when my radius doubles, my volume quadruples. So again, the constant didn't really change the proportion. Easiest thing to do when you're given an equation on the test and you're not really given any numbers, you're just told that your input doubles or your input quadruples or your input halves, just pick numbers, plug, and then compare your outputs. Or if they're telling you to work with your outputs, change your outputs around and then see how your inputs change. But anyway, there's plenty more practice with this below. Hopefully this worksheet convinced you of the importance of completing the worksheet, developing these tactics, because not every problem is going to be a straightforward algebra problem. And sometimes it's just easier to think laterally or outside the box and to use tangible numbers to help you process what's in front of you. Anyway, good luck with this worksheet, and as always, come back for any more tips and help with any other concepts.